totally agree. How'd you know that? What, Lauren? Oh, kid. So -3, +4. I go left 3 and I go up 1, 2, 3, and 4. True? What did I mean by draw a triangle? The origin? Because I'm saying go over 3, up 4. Okay, fine. There's the right triangle. Can't I label this adjacent side as -3 and this opposite side as +4? Do you know where my theta would be? Would it be outside or would it be inside?
Inside.
There would be an angle inside, but not this angle. We're going to learn today something called a reference angle. The reference angle is a little guy inside the triangle itself, but actually theta is the guy outside, because theta is what gets us to the second quadrant. Does that make sense? We have to get to the second quadrant. It's just alpha. It would have been in the first quadrant. Theta gets us to the second quadrant. Alpha is the guy whose triangle we're looking at. And ironically, for theta, we see ratios. Wait, what's the hypotenuse? Got it. So then hopefully, if you guys were able to get the picture at least somewhat, you were able to figure out that sine is 4/5, cosine is -3/5, and tangent is 4 over -3, which technically is not simplified. We would say it's a -4/3. Kind of like that. We just don't really write the parentheses. But the negative in the bottom made the whole value negative. The negative in the bottom made the whole value negative, which is why we write it like this. How'd I find it? SOHCAHTOA. How'd I do SOHCAHTOA? I got myself a triangle. What I look at in the triangle? The opposites, the adjacents, and the hypotenuses. Hypotenuse? Don't know. All right, with that, let's go ahead and grade section 4.3 because it was on the triangles, and I guess triangles are still important, and I guess trig is still important. So let's go ahead and finish up section 4.3 first. Do I have it open? Yeah, I do. All right, here we go. Number 12. Oh, my goodness. You were supposed to find a lot of stuff, weren't you? Let me give you a second. Ooh, there's a note. That's exciting. Oh, it's just someone's homework. Page 216, numbers, I don't even know what. Okay. Number 12, it was super weird because the two triangles were totally different sizes, but what ended up happening for their SOHCAHTOA CHOSHA cows?
They were congruent.
Yeah. And why? Because trig functions are not dependent on the size, they're dependent on the ratios. And what do you notice with 1 to 2 and 3 to 6? That can be reduced to 1/2. Yeah. So all the trig ends up being congruent. You would have had to do Pythagorean theorem. That ends up being √5. This one ends up being root 3√5 because it's 45? Yeah. And 45 can change into √9 times √5. √9 is 3. But when you take the ratios, they end up being congruent. Good math word. Because the triangles are what we would call similar, and CP, CTC, corresponding parts of, oh wait, no, that's congruent triangles. What's the one for similar triangles? Maybe there's not like a nice little, yeah, I think it's more words, huh? Their sides are proportional. The ratio of their sides are proportional. And you're right, Joe, they are with the same angles. Number 24. Did you have to go to 60 degrees? Huh. I would have just stayed with pi over 3. And said that tangent of pi over 3, if you drew the geometry triangle, you could say opposite over adjacent. If you did the cheater chart, couldn't you have, ooh, cheater chart, that's a thing? Cheater chart, tangent, he's the bottom. And that's with our 0, pi over 6, pi over 4, pi over 3, pi over 2. He goes 0, square root of 3, over 3, 1 square root of 3, undefined. Okay. Pi over 3 would be √3. Dun, 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 dun. Ooh. Can you guys find the typo? There's one typo. Where is it? The answers are right, but there's one typo in the work. Can anyone find it? Yeah. Yeah. It's supposed to be 56 whole degrees plus 8 60th degrees plus 10 3600th degrees. Yeah. 56 plus 8 60th degree plus 10 3600th degree. That's just building bridges, right, guys? 60 minutes in a degree, 36 seconds in a degree. There is something spiffy with your calculator. I'm pulling it up real quick. Oh, it's going to cover your answers. I'm sorry. How do you do secant in your calculator again? 1 divided by cosine of. You can actually use, I need to put in my license, don't I? Uh-oh. In your calculator, you do 1 divided by cosine. Hey, that's that property. That's that identity, the reciprocal one, right? But here's something spiffy. You don't have to do 56 plus 8 60ths plus 10 3600ths because our calculator actually, let me make it pretty. The nice little fraction. Our calculator actually knows, hold on, degree mode, right? Okay, good. Our calculator knows degrees, minutes, seconds. Has anybody found the angle menu, which is second apps? There's a degree mark. Yeah, there is. If we're looking at this guy, we could actually go ahead and put in, I have to get back there. It was 56 degrees, right? I can put in my degree mark. There he is. I can put in my, okay, I can put in my second apps, the angle, minutes mark. Oh, I did the wrong one. Lame sauce. But some of you are already noticing, does number 3 look like seconds? Second angle. It is? Sorry, it's not. You can try it. It's a little baby r. Doesn't mean seconds, though. Well, how? Hey, aren't the seconds mark roughly similar to a double quote? Isn't a double quote like a character on the keyboard? Hey, doesn't your calculator actually have like letters on the keyboard? Where's a double quote? Guess what? They didn't want to make a second function for it. Anybody find a double quote? Alpha, I know, awkward. Oh, I have to get back to my spot, sorry. Alpha plus. I know it's weird, but they made it mean 2 things. A double quote when you're writing messages, but also a seconds unit when you need it. Dun 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 dun. Oh, look at that. Oh, that's kind of spiffy. Alpha plus. Were you guys able to do the math and or use the identities to solve the little baby puzzles? Foiling got you 1 minus cosine squared when you started with your given. Foiling got you 1 minus cosine squared. You could have done a couple different things. They said, isn't 1 sine squared plus cosine squared? Yeah, that's one way. They said, isn't 1 sine squared plus cosine squared? Yeah, that's one way. Cancel out sine squared. Some of you might have figured out that cosine squared is 1 minus sine squared. That would have worked too. And some of you guys might have said like, hey, that's just a rearrangement equaling sine squared. However you went, whether here to here, or whether here to here to here, or whether here to its substitution to here. Hopefully you got it to match. 54, super similar. They went ahead and solved for cosine squared in that Pythagorean, which is 1 minus sine squared, and simplified. You could have tried the other way. Sine squared is 1 minus cosine squared, but the struggle is you wouldn't have ended here. That wouldn't have been very helpful. So remember, with all those identities, just a quick little look back, because we were playing with this yesterday at some point. A quick little look back. Remember how I said you can rearrange these identities to help you with what you need? So the same way that we could solve for sine squared by moving the cosine squared, we could also solve for cosine squared. I'm not going to write all of his different variations, but we could solve for him by moving the sine squared. And that's what they ended up using in this problem. They rearranged that Pythagorean. And then it was possible. 64 was one of those triangles missing a piece or something, right? They used tangent. It was the best one with opposite and adjacent and solve, solve, solve. They went ahead and did it a little bit of a funny way because this is a unit circle value. Could have also done it with sorry, my voice is getting funny. You could have also done it with square root of 3 over 3. Could have done some cross multiplication, couldn't you? Root 3x equals 90. And you could have said x is equal to 90 over root 3. Then you would have had to rationalize. 90 root 3 over 3. Square root of 9 is 3. That would have worked also. For some of you, that might have been a little easier. They kind of used a harder way of looking at the square root of 3 over 3. Number 70, similar. You had to figure out who you wanted to use tangent, but this one, oh man, go to your calculator. 54 degrees is not in our unit circle. And check your rounding. You probably did more decimal places. Just make sure it rounds to 137.6 that you could make it match if you needed to. And I think with that, yeah, we have a random blank page. That's weird. Let me get rid of that real quick. There we go. All right, I'm ready for questions. What do we got? I'm going to freeze the screen so I can go get your first question if you have one. No? Not too bad, huh? All right. Then, to that end, let's go back to our notes. Section 4.4, trig functions of any angle. Wait, isn't that what we've been doing? Finding trig functions of angles? What's different in section 4.4? Guys, this is an old something, something, something. Wasn't that homework number 25? 26? 26, okay. Yeah. So 4.3 is today's, right? So we're on 27, true?
Yes.
Oh, for those of you guys asking about the quiz, it'll be like this. I'm going to give you a sine, a cosine, a tangent, a cosecant, a secant, a cotangent. I just want one of an angle. One of an angle. One of an angle. You get to choose what you want to use, as long as it's something that does not use a phone or someone else. You get to choose what you want to use. All I'm going to give you is this and this and this. Not literally, but like that. I'm going to probably give you 5 of them and a bonus. That's usually how I do it. 2 points each. 1 point is can you get the right sign, positive or negative, indicating you're in the right quadrant, thinking of the right function. Can you get the right sign? That's 1 point. So if you got a positive, or if you put a positive answer, sweet, there's a point. And if you got the numeric value, you get another point. So 2 and 4 and 6. Except for the only weird one is sometimes things are zeros or undefined. I can't really do like a sign on an axis because there's not really a positive, negative if it's 0 or undefined. So that one, it's like if you put the 0 and it's supposed to be undefined, I'll probably give you a point. Or if you put undefined, it's supposed to be 0, I'll probably give you a point. But other than that, I'll give you a point for positive or negative and a point for the value. Let me get out of that. Let me get out of this. Okay, section 4.4, trig of any function. Oh, we already did that. It's up to you. Pause. It's up to you whether you want to write this page. Because stop and check what it's actually saying. What is it actually saying? Yeah. It's just saying all students take calculus. And I already showed you that because you could have already been using it. Okay? So maybe some of you, especially if you never learned that trick last year with all students take calculus, maybe some of you, this will be helpful. All. Right? We say all. All are positive. And not just all of these, but also, isn't cosecant built on sine? So he's positive. Isn't secant built on cosine? So he's positive. That's kind of what's going on for all these quadrants. This one, when we say students, sine is positive, right? Which means not only sine is positive, so is cosecant, right? But everybody else is negative. When we say take, tangent is positive, but not just tangent, also cotangent. And when we say calculus or chemistry or classes or whatever you want to say. So some of you, it's helpful just to see the chart and be like, oh, that's what you meant. But it's not just, well, all is all. But it's not just sine, it's cosecant too. Not just tangent, it's cotangent too. It's not just cosine, it's secant as well. Good? So it's up to you what you want to write. If you do want to write more of it, grab out your phone real quick and take a picture. One of the reasons I don't necessarily make you turn in your phones every day, as long as you keep on showing that you can be responsible with it. But we're going to go ahead. For those that already know and use, all students take calculus. Are we okay? A couple more are getting it. sorry. But I think it just turned off, right, Jason? The air just turned off? You can kind of hear when it turns off. I figured you could feel it better, but maybe not. I think it goes on either side. Joe, it turned off?
Yeah, it's like split in all directions.
Literally, huh? All right. We were talking just a second ago about this guy called a reference angle. And we actually had, in our first problem in the notes, we had a theta that landed in the second quadrant. And we made a triangle where you could talk about an alpha, but he's not the theta. He has the same triangle, but I need to get in the second quadrant. So theta is going to land somewhere. And when he lands, I can make a triangle. But I need you guys to know where we make the triangle. Some people would make it the wrong direction, and then it's not going to work. Not even close. We need to make the triangle with the axis of the initial side, or connecting the terminal side with the axis of the initial side. So remember, with any angle, as you guys are writing this, there's an initial side. We extend that. And then there's a terminal side. And we connect the terminal with the axis of the initial. We never go into the vertical. We always go either up or down to the horizontal. Or I should say, we always go to the axis of the initial side. When talking about navigation, we don't always go from due east. Like if we were to expand this and use angles in something practical like navigation, we don't always go or measure from due east. Due east is standard position in math, but we don't always measure from due east. If you're talking about a compass, sometimes we measure from north, like northwest or southwest or southeast. We don't always measure from east. We usually actually measure from either north or south. In which case, standard position actually wouldn't be a horizontal line, it'd be a vertical line. So this wording is all to be able to be used however you measure an angle. In math, we're always measuring standard position from this guy right here. But in other applications, sometimes that changes, which is the end of chapter 4. Chapter 6, sorry. Trig just kind of blends together. It's either the end of, no, it's not the end of chapter 4. Sorry, nope. Chapter 6. Chapter 6. But anyway, reference angle, he's my alpha. Not Mr. Jones, but he's my alpha. Reference angle. He's the alpha. He's the guy inside the triangle. And some of you guys might be able, this might draw some connections as far as how we do the unit circle and why we do the unit circle the way that we do. But for right now, reference angle, the little guy in the triangle. So theta can land all over the place. Now theta could technically land in the first quadrant. He did, he's alpha. He's the guy inside the triangle. It's not that big a deal. But if theta lands in the second quadrant, or if theta lands, oops, I don't want that, in the third quadrant, or if theta lands in the fourth quadrant, where's your reference angle? This time, the reference angle is actually kind of overlapping theta to get my triangle. In this one, no, always smaller than 90. And then this one, alpha is actually outside. Alpha, or the reference angle, is always the guy inside the triangle that would be formed, that would be properly formed with the axis of the initial side, or in our case, with the horizontal or the x-axis. For our purposes, yeah. But if we're doing compass bearings, is what we call them, Joe, it kind of changes. Because we're measuring from north-south, not east-west. Or you will see it. Not this chapter. But for right now, we're always going to the x-axis. Drawing a triangle to the x-axis. And we're always looking at the opposites and the adjacents. The opposites being a y measure, the adjacents being an x measure. The opposites always being a y measure, the adjacents always being an x measure. And if this ever changes, you've done it wrong. The opposites being a y measure and up and down. The adjacents being a right-left. It keeps us all honest as far as how we do our opposites and our adjacents, and hence Oh, he's in the wrong spot. Our hypotenuses. Still not sure that's plural. But how do we find alpha? Let me give you an example. What if theta was 140 degrees? Can anybody tell me what the reference angle would be if that was 140 degrees?
40 degrees.
Yeah, because what did you do in your head? Math. What math?
Subtraction.
Subtraction. Subtracted what from what?
180 from 140.
Oh, so 180 is what you used. 140 is the theta, and you were finding the alpha. Hey, that always works if you're in the second quadrant. You're just saying how much more to get to 180, or radians, how much more to get to pi. Okay, so if you're in the second quadrant, reference angle is how much more to get to 180 or how much more to get to pi. In the third quadrant. Nope. Do you see why it's not 270? We have to go to the 180 still. We're just going to the 180 a little bit differently. So if we're doing the third quadrant, making a little more room, who's bigger? My angle, my theta. So I could actually do alpha is equal to theta minus 180 or theta minus pi if you're in radians. But here's the snazzy thing. You actually don't have to remember anything different than the one up above. If you just realize, hey, you're trying to take away from 180 or you're trying to take away 180, we could actually use these exact same formulas, except reference angles always have to be positive. So if we do 180 minus a bigger number, isn't that going to be a negative? If reference angles always need to be positive, we could just throw in absolute values and say, whatever, subtract the 2 and make it a positive number. Makes it a little bit easier. If you're in quadrants 2 to 3, you're subtracting from your close to 180 is your horizontal angle. You're close to that. Just subtract the 2 and make it a positive number. That's your reference angle. But if you're in the fourth quadrant, you're not close to 180 anymore. You're not close to 180 anymore. What are you close to? 360. So we're just going to have to change and do 360 minus theta. Or radians? 2 calzones minus theta. So if you're in the fourth quadrant, sorry, that's another Greek letter. It went a little bit awry. There we go. So if you're in the second or third quadrants, you're close to 180, just subtract the 2. Reference angles are always positive. If you want to write a note to yourself, that might not be a bad idea. Always positive, never negative. I feel like that's something that could mess you up. Question on the quest next week. If you're close to 180, subtract from that. Make it a positive. If you're in the fourth quadrant, you're close to 360. Subtract from that. Make it a positive. Hopefully it already will be. So if I was to give you, ooh, my pages got out of order. I'm sorry, guys. Here we go. So if I was to give you these guys. If I was to give you these guys. $300 degrees. How many of you guys are in the fourth quadrant? Okay. Anybody thinking better in radians and you would rather see that this guy is actually 5 pi over 3? No? 1 2/3? Well, only 4 of you raised your hands that you knew it was in the fourth quadrant. For those of you that were able to see where the angle was at, for those of you that don't know where the angle's at, I'm a little scared because I thought you were better in degrees. How about now? 90, 180, 270, 300? Oh, so maybe there were more than 4 of you that can get there. Fourth quadrant? Are we there? Okay. So whether you go in degrees or whether you go in radians, 1 2/3, either way, you're going to have a reference angle of 60 degrees or pi over 3. Why? How much more to get to 2 pi? How much more to get to 360? Well, I only need 1 more third, or I need 60 degrees. Either way works. Now, 2.3 is a little bit worse. Well, there's no degree mark, so yeah. 2.3. Now, some of you are trying to get there. I'm hearing Joe say things like more than a half pi, less than a whole pi. Because, wait a minute, 1 whole pi is a half circle, 3.1415926, and 2.3 is less than that. Or if you want to think, remember, it's radii and a flexible ruler. So take 2 radiuses and fold around. 2 radiuses and fold around. It is going to be in the second quadrant somewhere. It's between pi and half pi. It's between 1.5 and 3.1415926. Somewhere in there. Yeah, let's not do 180 because that's not degrees. So to find our little baby alpha, it's not there anymore. Now he's over here. Alpha is going to equal pi minus 2.3, which is, I don't know. Who cares? That's the right answer. Could you put it in a calculator and get a decimal? I suppose. Oh, you could. So many no's today. Such negativity. Okay. How do you go a negative angle measure? Last class, someone just temporarily. Good. You go backwards, aka clockwise. 90 and a little bit more. Are we in the right quadrant of quadrant 3? Yes. Specifically, this could also be negative 3 pi over 4. 45s are fourths, and it's a 3/4 angle in the third, negative 3/4 angle of pi. So isn't alpha this little guy? He's close to 180. Some of you are able to be like, oh yeah, easy, it's 45 left, because you know that he's 3/4 and there's 1/4 missing. Could go ahead and remember, only positive numbers, not negative. It'd be 45 degrees over 4. That's missing. As far as the math to get there, it's a little bit rough. If it's the math. You don't want to do minus negative 135. That's way too big. I don't want negative 180 minus 135. That's not a good idea. But I could do 180 minus the absolute value of 135. And that would work. Basically, I just want to figure out what's in between. I could also do negative 180, what Joe is starting to say, minus negative 135. You could do that also. You always want an absolute value. Long story short, you will end up with somehow, hopefully, if you take them away from each other, you are going to end up with a 45. Just remember to make it positive, and then you're okay. Reference angles, a little baby guy left over, either to 180, pi, or to 360, 2 pi. Okay. Why do we talk about that? Well, because technically they're just trying to help you out when you get to trig functions of guys bigger than the first quadrant, even though we've been doing it already with the circle. They're trying to help you out if you're doing it with triangles. So technically what they want you to know, just because you might get confused if you don't know otherwise, they want you to know that when you draw a location of an angle, if you're trying to make a triangle for Sokotoa Choshikau, they're trying to teach you, you always have to go to the x-axis for a unit circle. You always have to go to the x-axis with that triangle. If you like the triangle idea, you always have to go to the x-axis. You're looking at the triangle with the reference angle, the proper reference angle inside. And they call the reference angle this little theta prime dude. Hey guys, P.S. You already wrote all this? You're starting on number 2. Oh, sad day. I thought you'd see it. I'm going to call him alpha. They call him theta prime. So the steps are to first do the whole reference angle-y thing, and then second, set up a triangle using that reference angle. So when you do Sokotoa Choshikau, you're not technically using theta's triangle. You're using theta reference angles. And then solve for Sokotoa Choshikau. Watch out for signs. All students take calculus. So we've already been going to the second, third, fourth quadrants. We've already been going to the second, third, fourth quadrants. They're just trying to tell us how to go. how to go there with triangles, basically, and how to legally go there with triangles. Okay. So the crazy thing is section 4.4 might not be that much different than what we've already been doing. Oh my goodness, it looks like what I've been giving you guys in the back of your homework spiral, doesn't it? But I'm going to solve all of these with triangles just to show you what it's like. Doesn't mean you have to do it that way. Some of you who are like, I like the circle, I like the cheater chart. Okay, okay, okay. Just hear me out with the triangles just in case it might work better for your brain, okay? Just hear me out with the triangles just in case it ends up working better for your brain. So, this is not working, I don't know. With the first one, cosine of 4 pi over 3. Let's use our tricks. 4 pi over 3, where does he land? You guys agree?
Yeah.
One whole calzone, a little bit more, huh? Kind of a big slice more, right? So this one's going to land in the third quadrant. I'm going to pause really quickly. Can you guys write these three down and show me the location for each? Pause, no talking. Just a few of you, people are calling out answers and you don't even have a time, you don't even have a chance to process where yourself. So this first one is going to be in the third quadrant. But can you figure out where the second and third ones are? What happened to not talking? Lauren? I'm sorry, what? We're not doing a lesson specifically on, but I'm going to show it one more time at the end of class. It's not so much a lesson, it's something that you can memorize, but we'll try to use it. Couldn't give tons of time. I just wanted to see if you can get in the right quadrant. Negative 210, no talking. If I were you, I would have thought 90, 180, and a little bit more. 90, 180, and a little bit more. And for 11 pi over 4, I would have thought 4/4, 8/4. I'll send you out if I need to. 4/4, 8/4, and then I go another 3/4. I'm going to end right here. Now, as I look at each of these, you guys could visualize triangles, but I need to make sure you're visualizing the right triangles, the correct ones. Each time, if you're thinking about triangles, you're going to go to the x-axis, like you guys saw with the reference angles. And technically, if you were to think reference angles for each of them, bless you, you could think this guy's close to 180. How far away? Technically, he's 30 degrees away. There's a little bit of 30 degree in there. This one is close to 180. Well, he's farther away. He's actually 60 degree away. And this one is also close to 180, but he's technically a 45 degree away. Now you could think of he's a pi over 4 away. He's a pi over 6 away. He's a pi over 3 away. But if you're able to figure out how he is from the axis, you can actually think of the triangles that would correspond. Now maybe you like my way of thinking of the different possible angle values, like I do with my cheater chart of how sine, you're alive, how sine counts up through each of the special values. And you might think of, hey, that's 0 on an axis. That's a little, that's a middle, that's a lot. Middle, little, lot. Like maybe you think of that, and maybe you could fill in your x's and y's with your triangles based on that, in the sense of over a middle, up a middle. But you could also think of how that's going to be 1, 1, root 2 if you think of geometry. Either way, you'll eventually get to root 2 over 2, root 2 over 2, either in using rationalizing or in using the point. This one with a little, over a lot, up a little, you're going to get your 1, 2, root 3 if you think geometry. Or if you divide your over a lot, which is going to be a negative number, up a little, which is going to be a positive. Maybe over a little, down a lot would get you there. Maybe your geometry, root 3 by Jason 1 and 2, remember your negatives. But maybe you could also get to your negative 1/2, negative root 3 over 2. But basically, this section is just telling you how to legally draw the triangles to get to what you want. Whether you use your geometry triangle of adjacent over hypotenuse, or whether you use the x of the point, or whether you, Lauren, you ready? Or whether you get down the cheater chart to where you can write it on your own, blank piece of paper. The quiz has started. Now you write it. And maybe you just look at an angle and say, hey, he's a third. He's an over 3. Line it up. Cosine of an over 3. Isn't that 1/2? That's the right number. But we need to think about the third quadrant. All students take, is cosine a positive or a negative in the third quadrant? A negative. So whether you use adjacent over hypotenuse, whether you use over a little, left a little, or an x, or the cheater chart, a 1/2, ooh, third quadrant, make it a negative. All ways will get you there if you do the way properly. Tangent of negative 210. Negative 210, ew, that's a little like extra 30-degree guy. Oh, that's an over 6. Tangent is root 3 over 3. But all students, tangent's negative in that second quadrant. Or maybe you would have used your opposite over adjacent and had to rationalize and gotten there. Or maybe you would have used your y over x and rationalized to get there. All ways would get you there if you use it properly. And cosecant of 11 pi over 4, for some of you, it's probably best to think of 1 over sine of 11 pi over 4. If you figure out that's the second quadrant by turning properly, the triangle, hypotenuse over hypotenuse over opposite would get you there. Or flipping sine would get you there. It might be kind of nasty. Or flipping the sine of an over 4 would get you there. Let me show you that way, because you would flip it and get 2 over rad 2. All students, sine is positive in the second quadrant, but you might need to rationalize, which is kind of gross. But it does get you there. Do you have to make a triangle? No. Could you use x's and y's? Yes. Can you use the cheater chart? Also yes. Also yes. But how does the cheater chart work again? If you can figure out, for instance, letter C is kind of gross because it's a flips sine. You could take an over 4 and say, whose sine? There he is. Let me flip him. Shoop. The problem with the cheater chart is you have to double check every answer with all students take calculus, because this only shows what quadrant? The first quadrant. So you would need to think of what is sine in the second quadrant or cosine in the quadrant, etc., etc., etc. Hey kiddos, how do I do this chart? Sine counts up 1, 2, 3. Cosine counts down 3, 2, 1, all over 2 and square rooted. That's awkward. It's not in the song. Square root of 3 over 3, 1 square root of 3. Done. But you kind of need your ends also. Luca helped me out. It was from Brazil. He learned it when he was in middle school. It's up to you guys if you want to try to use it. But one way or another, there's going to be a quiz on Tuesday. Once the quiz starts, you're allowed to draw a unit circle, draw a first quadrant, draw a cheater chart, or just go with your knowledge of the unit circle. Can you guys do it? Work this weekend. Bye, guys. Plenty of unit circle study things online. Plenty, plenty, plenty. Find a way that seems to work with your brain and stick with it. Find a way that works with your brain and stick with it. If you need another help, come in after school. I didn't do that one.